For those who don't know me, I'm Thimantha Vidanagamage. I love working with Microsoft Data Platform technologies such as Microsoft Power BI, Azure Analytics Services, and Azure Data Factory. The most important thing out of all the details that you see in the screen right now is my Twitter handle at Thimantha. So please follow me on Twitter at Thimantha. Moving into the agenda for today, firstly, I will take you through some basics of semantic models as I did with the training sessions. And later on, we'll look at some important aspects of an effective semantic model and reasons for an ineffective semantic model. And finally, I'll be wrapping up this session by showing you guys those some of those features and uh, features and functionalities that would really make a difference. Uh, that would really make a difference in your semantic model, so your data models. Right. So moving into the basics of semantic models, semantic model is also known as a data model. So just keep that in mind. Data model and semantic model, it's literally the same. Uh, it's just it's just another, it's more like a similar word that you use, a synonym that you use. Those two are ideally the same. So uh, a semantic model is simply a data model, or a model that's catering for end user analytics. So end user analytics means it would cater uh, analytical purposes of the users in an organization or company who engage in data-driven decision making. And these semantic models are two types. There are two types of semantic models. These are tabular semantic models and multi-dimensional semantic models. Previously, it was just multi-dimensional semantic models, and later on, tabular semantic models came up. So tabular semantic models are a lot more compressed compared to multi-dimensional semantic models. And in this session, we would entirely talk about tabular semantic models because you can only develop tabular semantic models with Microsoft Power BI. A semantic model follows a basic concept between a fact and a dimension. Fact is an aspect. A fact is a table with numerical figures, while a dimension is an aspect of looking at a fact. So a fact can be sales, and a dimension can be region, and regional sales can be analyzed with the combination of facts and dimensions. When it comes to the semantic models design, there are two key semantic model designs that we follow in the industry. That's the star schema and the snowflake schema. So the star schema is the most optimized for analytical purposes, and it follows a fact table surrounded with dimension tables that are directly connected to the fact table. So it's highly optimal for analytical purposes. Snowflake schema is a bit complicated compared to a star schema, and it's not the most optimized for analytical purposes. It is where dimensions are linked with or have relationships with other dimensions as some other dimensions as well, which adds a bit of complexity into the data model. However, there are situations where we should go with the snowflake schema based on the business requirements, but if we can stick to any situation where we can stick to a star schema, we would always stick to a star schema. And it's when it cannot be, it's when a situation cannot be handled with this star schema that we would always move to a snowflake schema. Right, moving into an effectiveness of a semantic model, there are two key aspects of an effective semantic model. One aspect is the usability, and another aspect is the performance. Usability is simply how easy it is for you to use this the semantic model, and performance is basically usability is how easy is the data model or the semantic model is to be used by the end users, to be consumed by the end users, while performance is about how performant is whether if the model is at the optimized performance is basically if the model is optimized enough to cater analytical purposes and whether it's lying in an optimal stage. So when it comes to an effective semantic model, uh, you can't there an effective semantic model can't be a semantic model that's highly optimal or doing really good in performance, but does not have uh, uh, a decent record in terms of usability. I mean, it is it might if a data model does not have maintain a good level of usability but is doing really good in performance, that does not mean that that's an effective semantic model. That's just a highly optimized semantic model, but and that's not an effective semantic model. And if you look at the vice versa, if you look at a situation where a data model is uh, doing really good in terms of usability, but doing really poor in terms of performance, that does not mean it's an effective semantic model as well. So there should always be a balance and combination between usability and performance in order to build an effective semantic model. And yes, there can be other aspects such as security and many more aspects that come into play into an effective semantic model as well. But these two are the key features from a Power BI developer's point of view to uh, improve the effectiveness of a semantic model. And moving into the reasons for an ineffective semantic model. Now, we talked about the effective semantic model, the aspects that that serve an effective semantic model, which are usability and performance, and looking at why are these, I mean, uh, when it comes to the ineffective part of things, we need to understand what are the reasons for an ineffective semantic model. So the one main reason that I see here is that we have evolving features and technologies. For example, if you take Power BI, you have monthly updates every time, and it might not be not feasible for it. It might not be not. It might not be feasible enough for everyone to keep hold of all these features and technologies that are coming up, right? So there is definitely uh, hold back there, but it's always necessary for us to be updated with the latest features and technologies in order to keep our some data models up to date, right? So that's something we all need to take into consideration, and that's one of those reasons why I am doing this session as well. And another reason for an ineffective semantic model is that the stakeholders who are involved in this data model or this data analytics solution, we could say, might misunderstand the potential for business value that generates from an effective semantic model. So they might not realize uh, how an effective semantic model might cater their business value. And as a result, all they would care is that they have the correct data in their reports and they would have their requirement fulfilled, and that's about it. And they wouldn't deep dive and think and analyze any further in order to the deep dive and look into things any further in order to uh, uh, get things to a better stage. They would be satisfied with the business requirement that's being fulfilled at the moment, at the current stage. So that's really one of those reasons. Uh, uh, that's really one of those reasons to not under for stakeholders to not understand the potential business value that an effective model can build. So simply they won't care if the model is effective or ineffective if they have the right data in their reports and if the business requirement is fulfilled accordingly, which is not really the right way to go about things, but that's a really difficult culture to change, and yeah, that's a really difficult mentality to change, to be honest. Right. So that takes, now we have talked about uh, some basics of semantic models, and we have talked about the two key aspects that affect that make a semantic model effective, which are and performance. And we also looked at the reasons for an ineffective semantic model right now. Now let's look at the two key aspects which make a semantic model effective, which are usability and performance. Let's look into what are certain things in usability, certain little things in usability that could little differences in usability that we can do to make a massive difference. So the first thing I would like to focus on is measure groups and tables, right? So in terms of usability, so the usability of the model is obviously improved when you organize your measures and attributes accordingly uh, to because it would be easier for the folks who are engaged in self-service BI specifically, and not specifically if you have fixed reporting requirements. This would be beneficial if you have self-service BI requirements in place, right? So if you basically are a self-service BI guy if you are someone who is engaged in self-service BI, this would definitely be you. This is something that would definitely work out for you, which is measure groups and measure tables, because you would when you put measure groups and measure tables in place, you would be able to uh, navigate uh, navigate through your measures and attributes much more easily. And that would be really beneficial for you to get your analytics work done pretty easily. So that's that. And without further explanation, I would get back into the demo of this. So to demo you, just to demonstrate you how to create measure groups and tables and how to organize that, I have a separate data model that I have set up here. So this is the data model actually, and it has two fact tables and some dimensions as well. So what I'll be focusing on here is how to implement measure groups and measure tables. So how you do that in the first place is uh, simply what first thing what you want to do is create a measure table, right? So what does a measure table does? A measure table would organize all the measures that you have everywhere into a single location. So that's something that's required, right? So then it would be easier for end users who are consuming the model to engage in self-service BI. So let's do that. So that's the first thing that we'll be doing. We would be creating a measure table, and creating a measure table is very easy. Navigate into the home tab and click on the enter data option. And under enter data, you would need to just have a single dummy column and have an appropriate name for the table. I would call it sales, and that's about it. And you have your measure table in place, and the next thing what you want to do is you want to migrate all the measures that you have in here to this particular sales measure table, right? So how do you do that? That's simply very easy. Just copy it and just delete the existing one from your model, and just get into the respective table and click on the new measure option and just paste the new measure right there. That's how we go about that. And you can see as a result of that, we are getting some errors in certain uh, uh, certain other measures as well. You can see the last year measure, it refers to an internet sales amount that's in the internet sales table that does not exist anymore. That's so that exists in the sales table. So we would remove the internet part, and that should solve our things. And the next, you want to do the same thing for everything, but I would not waste time doing that. I would just do it for two of them, and uh, and the rest would be just a replication. So I would not be doing that. So what I would do is I would copy this once again, which is the reseller sales amount, and I would delete that from the model. And I would click on the a new measure option under the sales table, and I would add this measure in. And that's about it in terms of creating a measure table. And I just need to correct this once again. So this is referring to a reseller sales amount in the reseller sales table, which does not exist anymore. It exists in the sales table. So I would leave it that way. So it should ideally replicate for everything that you see right here, but I would not be doing that. I guess I'll do it for two of them. So because it might need, yeah, it might be needed for our next demo. I would just take this, which is the last year internet sales amount, and I would copy that, and I would delete it from the model, and I would paste it back. As a new measure in under the sales table, which is our measure table, and I would replicate the same thing for reseller last year reseller sales amount as well. I would just take a copy of that. I would just take a copy of the measure and delete the existing one. And paste it as a new measure in the new sales table. So that's about it. And the next thing what you want to do is just hide this dummy column, which is just with a full stop. So just hide it because that's just there to like make sure to get the table in. And other than that, you don't need that. So I would hide it, and that would create a measure table for me, right? You can see the calculator icon right next to sales, which means this is a measure table now. And I would not need the reseller sales and the internet sales anymore, so I would hide that too, those two as well. I hid reseller sales and right click and hid internet sales. So I just have the sales figure and required sales measures right now. And the next thing what I would do is I would create measure groups, right? So how I would create measure groups is I would navigate myself to uh, the model view. And after I navigate myself to the model view, I would click on a respective measure. In this case, it would be internet sales amount. And what I would do is uh, I would provide at appropriate. So I would just click on the measure, and when I click on the measure, the properties of the measure should pop up, as you can see in the screen right now. And inside those properties, what you should pay attention to is this display folder. Uh, display folder property, which is all about creating a measure group. So how you do that is simply when you just enter a particular any folder name. So if I say internet sales, it would create a measure group or a folder uh, with with the internet sales amount inside a folder called internet sales. And if you want more measures inside that folder, that particular internet sales folder, just copy that and just navigate to whatever the measures that you want uh, that you uh, want to have in this folder, and simply navigate to the display folder property in that particular measure and just paste that, and you should be able to see. Uh, both the measures in that particular folder. So you can see a clearer view of that in the reporting view, where you can see the internet sales amount, the last year internet sales amount under folder. So that's that. And the next thing what you want to do is you want to replicate the same thing for reseller sales as well. So just click on the reseller sales amount measure and just enter a folder name for display folder as a reseller sales and enter a folder name for last year reseller sales as a reseller sales as well, so that would create my measure groups accordingly. And you can also replicate the same thing as attribute groups. You can call them attribute groups with dimensions as well. For example, if I take the product dimension, if I want to just isolate my product name as my base measure, so what I would do is I would just click on the product name column attribute, and I would navigate to the display folder once again, and I would just type out this, and it would create a separate folder called this. And as you can see in the screen right now, and if I want to just categorize the remaining columns into if I want to categorize the remaining attributes into another group called other, I would just type the display folder as other, and it should appear right there. And if you get see a look at the product dimension from the reporting view, you should be able to see these folders categorized accordingly. As you can call them attribute groups, but technically it's measure groups that you use for attributes. So that is that. That is demo number 1 for you. And next up is the second use technique to improve usability. So, I would say this is a performance. This is something that affects performance as well. So this is called calculation groups, and this requires an external tool called Tabular Editor for you guys to use. What you do with this is reduce redundant. So with calculation groups is ideally a feature that allows you to minimize measures with the same calculation logic or expression. So in this scenario, uh, so that's a bit about that. So I guess without talking much about it, I would simply demo that so that you guys would understand it as well. So if I navigate myself back into the calculation group, uh, if I navigate myself back into, the data model, and in the data model, you would see under sales that I have certain measures that follow the same logic, right? So you can see the last year internet sales amount that has the same logic with previous year, and the last year reseller sales amount that has the same logic with the previous year, right? So it's literally the same logic used. The only difference is that reseller sales amount is the base for the last year reseller sales amount, and for the internet sales amount, the base is the internet sales amount, right? So that's about it. So that's just a replication of logic, uh, a replication of logic, right? So what you want to do is introduce a calculation group instead with with a calculation item called last year, which would do the trick. So how I create a calculation group is very easy. Uh, I would navigate myself to external tools, and keep in mind that external tools tab does not appear if you guys have not installed Tabular Editor in your local machines or any other external tool. So you need to make sure that you install a Power BI external tool in your local machine in order to see the external tools tab in your Power BI desktop file. So in this case, I had installed Tabular Editor, which would be required for our calculation groups. So it's necessary for you guys to have Tabular Editor as well. So if you guys just Google in saying Tabular Editor download, you should be able to download it very easily and install it in your local machines. So there is no fuss about it. So it's really easy and straightforward. So after you do that installation, external tools tab would appear and you should be able to see an external tool called Tabular Editor. So what you do is click on this Tabular Editor. And when you click on this Tabular Editor, the Tabular Editor would open up the data model that you have in Power BI. And the next thing what you want to do is you need to create a calculation group, right? To create a calculation group, navigate yourself to the tables folder that's under the model, and just right click on that tables folder and click on select create new and click on calculation group, and that would create a new calculation group for you. And in this case I would call my calculation group as you just need to provide in this case you need to provide an appropriate a name for your calculation group. I would call my calculation group as India Time Intelligence. And if you drop down into the calculation group, you should be able to see two options called calculation items and the name. Name is simply the attribute name that would store all the calculation items. So you need to make sure that you provide an appropriate name for that as well. So I would just click on the attribute name, attribute name, and I would just rename it to time duration. So when you click on the attribute, you should be able to see the properties of that in this particular corner, in this particular part of the window. And you simply need to navigate yourself to name and just provide an appropriate name. That's about it. And the next thing what you want to do is you need to create the calculation items, right? So in this case, we just need to create one calculation item, and how you create a calculation item is click on the calculation item option and click on new calculation item. And the next thing what you do is when you create a new calculation item, you need to make sure that uh, you need to make sure that you need to provide an appropriate name for the calculation item as well. So I would call my calculation item as last year. And afterwards, what I want to do is I want to make sure that I provide a respective logic for this calculation item, right? To keep it running. So what I would do is the logic should be the last year logic. So I would navigate myself to last year internet sales, and I would copy that the logic that's already written for this particular measure, and I would paste it right back into the Tabular Editor. And that's about it. You have the logic in place, but there is a problem in this logic, right? Because it's referring directly into the internet sales amount as the base measure only. That doesn't work, right? Because you need to base the reseller sales amount to this logic as well, to this particular logic as well, when it's required. So in this case, we would simply remove the resellers internet sales amount from here, and we would use a function instead called selected measure. Selected measure would do is whatever the base measure that it is directed to, it would apply this previous year logic to it, and it would provide you with the previous year analytics. So that's simply that, and that's how it works. And that is simply my calculation group, and I would just simply save my calculation group right here. And I would refresh my calculation group. So what I just did was I saved the changes to my data model in the Tabular Editor, which means I saved my calculation group in my data model. How I did that was I clicked on the save the changes to the connected database option, or else you can also do that with file save option, and you can save your data model in the Tabular Editor. And to make it reflect in the data model, Power BI data model, you would get a message saying that uh, that uh, that the model calculation groups require a refresh, something like that. And all you need to do is click on refresh now. And in case if that doesn't appear, which had happened to me quite a while, all you need to do is just go to the home tab and just refresh your data model. And you should be able to see the calculation group if you had saved in your data model afterwards. So I can see my calculation group in my data model right now. So that's simply about it. And if I if I show you the usability of this, so use of this, so time duration is simply the attribute name that we provided, and you can see that the last year calculation item is inside this time duration, and we had provided that as a slicer right now. And the next thing what you want to do is we just need to bring in some kind of figure and just see how that works, whether there are any differences when you click on the last year option. So just getting a bit of error here, so let me quickly check that. Okay, so a small change that is required here. Sorry about that. So I would, I'm just because the previous year function requires a date field, and that means I should refer to a date field. So I just make sure that my date field is cleaned up. And the next thing what I would do is I would navigate myself to once again to the same logic that I just created, which is uh, the selected measure previous year logic. And I just instead of date key, I use date here because that is what's required for the previous year function. And once again, I would save my model. And yeah, and the change is replicating right now, right? I'm not sure why there is no difference, but there is definitely no errors, and it's referring to the previous year. So let me take back here and see how this works out. Oh, there seems to be some kind of problem in this relationship. Mm, nothing as such. Oh, wait. So the calendar table is not linked to this particular relationship. Oh, yeah. Yeah, so that is a mistake. Sorry about that. So the calendar table should be linked, which would make a difference. So I would not waste my time adding that because reseller sales already has that. So you should be able to see a difference, hopefully. Uh, Man. I think I would have to add this relationship. And I would just create a relationship here with date and order date key. And that would simply do it. Let's see how it works out now. And not really pretty sure why this is not working, but uh, I guess there's some kind of logic issue. I'm not pretty sure, to be honest. But let's not focus on that. I hope you understood the concept behind that in terms of how to create a calculation group and the benefit you get from the calculation group. I'm sure this is something to do with the logic. So let's just keep that aside, and let's move into our next demo. So the next part, next feature that I would like to talk about. So the next feature I would like to next I would say the next feature that or the functionality that would or the best practice you could say that would make a difference uh, in your performance. That is organizing your Power Query, which is all about just making sure that your Power Query is organized, and you should make sure that you engage in all the required Power Query steps in a particular plan. For example, like if you want to remove columns, you need to make sure that you remove columns only once in a respective Power Query. You shouldn't remove columns once and then afterwards you should there shouldn't be situations where you should have multiple repeating steps, right? For example, a very basic example is removing columns. There can't be any situation where you remove columns once and then you perform some other Power Query steps, and then again you realize that you have to remove some columns, and then you remove those columns right afterwards, which is a repetition of Power Query steps. That cannot really happen. So that is so that ideally happens with uh, uh, happens in certain cases, and I would show you an example of that. I'm not really sure whether I would have enough time for that because I need to rush for another session in 10 minutes. So uh, that so if I just take you through this customer dimension, so you can see that they are repeating steps, right? You can see that the remove columns is repeating. So basically you remove columns once, the unnecessary columns once, and afterwards you add a custom column for customer first name and the last name concatenated, and afterwards you realize that you don't need the customer first name and last name, and what you did was you removed it afterwards. Not really a best practice to go about things. So what you want to do is you want to make sure that you remove columns here itself and knock it down there. I mean, and remove columns in one single place and make sure that you add the custom column before removing the columns, right? So when you add the custom column before removing the columns, you can remove all the columns in the same time without any issue, and you can uh, engage in your development. So that's about that. Actually, I'm not going to do that because that would get me a bit of time. Just explain to you how that should work out. Uh, so that's it for my session. So I know it's a pretty short session, and I myself have taken today. It's a global Power Platform Bootcamp, and I have like around uh, 8 sessions to cover within a 12-hour span. So the last 2 sessions were in the next 2 hours. So I'm pretty busy, and I just want to make sure that I don't affect the timelines of the other events that are happening around the world as well. So I would stop this session from now, but I think we can do an extensive session on this topic uh, as a training as well in with the monthly meetup. But I hope you guys got something out of this session. I hope you understood how calculation groups work, how measure groups work, how measure tables work, and how you can use measure groups for attributes, and basically how you should optimize your Power Query. So those are the some of those few key intakes that you might have got from this session. And apologies for cutting short, but yeah, next time we'll definitely go for an extensive session and make sure that we get on track. So hope you guys are okay with that, and I hope my session, I hope you got something out of this session. Thank you, Asan.
Thank you.
So
Thank you, Thimantha. Thank you for your event.
no problem.
It was a nice session, and
Mhm.
we have uh, Power BI training session
Right.
recorded, and that is available in YouTube channel, and you will be uh, beneficial uh, by this session. Thank you very much, Timantha. Uh,
Right.
Hopefully, again you will join in another meetup. Thank you for today.
Yeah, of course. I am more than happy to do more meetup sessions and probably get you guys on track. So I think we did around 5 to 6 trainings during the past few around 5 to 6 training sessions during the last year, and we are I'm ready to go for the intermediate level now. So this is just a start. So we can simply accelerate from here and see how things go from here and get the folks up to date. So yeah, that's simply my target. So thank you, Hassan. So I guess I would uh, leave the session, the meeting right
Thank you very
now
much.
because right. Thank you very much. Thank you.
Thank you.
Thank you. Have a great day, guys. Thank you.
Thank you very much.
Thank you.
Michael, are you there?
Good evening. I'm here.
Good evening. Thank you very much. Um, we're just going to move on to the next session, and next session is on automate management task using Elastic Job in Azure SQL Database. Uh, Michael, can you please carry on? Thank you very much for joining Bangladesh community, and I hope it will be a very useful session for the audience. Thank you very much, Michael, for your time and effort.
My pleasure. So I'm going to share my screen now.
Sure.
Let's hide this one, and
Yeah, your slide is on the.
okay, excellent. So can I start, or should we wait 5 minutes till full hour? Is it okay if I start now?
Yeah, you can.
Oh, okay, excellent. So welcome everyone to the Power. What's the name? Power Bootcamp in Bangladesh.
No, Michael, it's a global power platform bootcamp.
Global Power Platform. Yes, sorry,
Yeah,
yes.
this event is arranged here in Bangladesh locally, but it's a global event. Thank you very much.
Excellent, thank you. So my topic is not strictly related to Power Platform, but I will be using Powershell. So yeah, there is a power in this session as well. So my name is Mikey Bronowski, and I'm going to present you the Elastic Jobs in Azure SQL Database. A few words about me. I'm going to move that window here. Excellent. So I'm database engineer for 9 days. Then I'm going to start a new role. I'm also a Microsoft certified trainer and Microsoft Data Platform since last year. If you have any questions or want to get in touch about something, my email is mikeybronowski@gmail.com. I'm on Twitter and on LinkedIn, and my handle on both services is Mikey Bronowski, no space. I have a blog at bronowski.it if you want to read some of my previous content as well. So let's start with the agenda for today. It's quite simple. I'm going to go through 3 things, basically. What are the Elastic Jobs in Azure? How we can configure them. And there I will show you 2 methods. One is the Azure portal, and one is the PowerShell, which I prefer personally. And the last bit is why someone would like to use the Azure Elastic Jobs in their environments. So let's go to the main thing. What are the Elastic Jobs? And that's the simplest explanation would be there are SQL agent in Azure. So Azure SQL Database does not have SQL agent, the one that we know from on-premises SQL Server. And if you want to do some automated task, there is no such thing as on-premises. So for Azure SQL Database, that you have to use Elastic Jobs in this matter. And the service itself, it's still in preview, and it's like that for past maybe 4 years, as at least the first time I read about them was 2018, so it's almost 4 years. And it's not only running the jobs, the T-SQL jobs. It has a few more features than the SQL agent on premises. You can compare that to master and target servers in SQL Server. If you're not familiar with the MSX and TSX, that's the feature of SQL Server where you can have one server and define the jobs on one server, which is called master server, and add the target servers to that definition, and the jobs will be created on target servers and they will be executed on the target servers, so you won't have to configure them on target servers. So that's in short what is the Elastic Jobs. And there are 4 main components of Elastic Jobs. That is the agent itself. So it's a service in Azure. We need to create that in Azure. For the agent to be properly working, we need to tie it to the job database. And the job database is a MSDB thing in cloud. So it will have all the system tables, system procedures. So when you look into the content of the database, it will look similar to MSDB on SQL Server on premises. 2 other components are target groups. Target group is a concept that I don't think it is used in SQL Server on premises. We can use CMS for on premises to have a group of servers when we have master server to push the job to targets. But in Elastic Jobs, it's a bit different. The target can be a server with all the databases. It can be a single database, pools or shard maps. And we have 2 options. We can include the targets, or we can also exclude the targets. So when we have a list of databases on the server, we can add the whole server and then exclude specific databases from the target group, which is not possible in on-premises SQL Server. And the last bit is the job. That's the task that will be executing the T-SQL against target groups. And the best would be if the job can be rerun. So the logic has to allow the job to rerun without any failures. So that's these are the components. And this slide, you don't have to read that through. I'm going to share that slide. It's a plan, what you need to do to create fully functional Elastic job and the targets and the job database. So we were talking about targets, we were talking about the agent, we have the target groups, Elastic jobs, but we also need set of credentials. And the credentials will be, I'm using the example of 2 credentials. One is the refresh credential, which is a credential set up on the target server level that allows the agent to see all the databases. So if one of our targets is the whole Azure SQL Server, the refresh credential allows you to see the databases. And when you create a new database, this credential will allow the agent to see the new database, which is good because you don't have to specifically add this database to the job, to the target group. And the other credential is job execution. That credential is responsible for running the job against the database, and every database that requires the job to be executed on will have this credential. So that's just an example of two credentials, but you can do any configuration. But the principle is to have least required permissions. So the credentials don't have too much power to do too much damage. But I will show you the plan, so you don't have to read this slide. You don't have to memorize that. And we will go through that. Especially it's more clear in the PowerShell demo. But you have to do this either way. So let's see first how we can create Elastic Jobs in Azure Portal. Let's switch to the portal now. So that's portal here. And I have a backup resource group that I created before that session, just in case Azure is too slow. And I will show you how to create that, but just in case it's slow, it's been created before. So where you can find the Elastic Job Agent. I have this in my quick access here, but it's called Elastic Job Agents. And if you want to create one, you can do that by creating it here. But the problem with this approach is you have to have your underlying database and server ready, because if I do the Power Platform agent here, I have to select the database. And if I don't have my database, the backup doesn't exist for me. These two are not available. So I cannot create new server from this wizard. So I have to go back, create my job database first and my target database first, and then create the agent. So let's create the SQL database. And the concept I'm talking about is a bit different here, because when you are creating the SQL database, you have the option to create the server as well. So when you're creating the agent, there is no option to create new database. You have to go back and create the database first. It cannot be done within the same process. So let's create the new resource group, which is BB portal, too many BB, and to YPP, PP, Power Platform. And I'm going to create PP portal job database. That database will be used to store the system processes. And I'm going to create the server. So it is PP job server. My location doesn't matter at this point. I'm just going to use East US. Hopefully it's not too slow. You need to provide the credentials to connect to your environment. Perfect. And that will be the new server. And now we need to configure the power, the performance bit here. So the minimum for job database is S0, standard 0. That's the minimum for the job database. The targets can be basic. When I'm going to create the targets, you'll see there is a basic option. But the agent has to be on S0. That's the lowest required. The next bit is the security, the networking. So I need to have a public endpoint to be able to connect to this solution, and two firewall rules. First is the Azure resources need to talk to each other. I will be creating different Azure resources, targets, and job servers, databases. And the other one is my IP address to be able to connect with Management Studio to that solution, because that's unfortunate, but I cannot finish the whole configuration within Portal. I need to do some stuff in T-SQL, and I will be using Management Studio for that. In this bit, I'm just going to leave the default here, tags as well, create. So my total cost will be around 13 euro for this agent job. Let's create that. And while it's being created, I'm going to create another SQL database, which will be my target. So I'm going to, yes, it's being created. Perfect. So now I'm going to create the target database. And it will be on different servers. So I'm going to use this PP portal resource group, PP target database, and I will be using new servers. I will create a new server, PP target server. And the other steps are very similar. So first, credentials, my admin account. Okay, it doesn't match. Fingers. Okay, that's being created, and now I can pick the configuration. So because I'm cheap, I don't want to spend 200 euros per month on my target. I'm going to pick the not here the basic one, the cheapest option. So it will be 4 euro. So it's about 3 times less than the agent job, and that's good. Now I need to allow myself to connect to the server. So very similar to what I did for the job database. Next, create 4 euro. Perfect. Create. And while it's being created, we should see one of them might be already created. So let's go to the portal. Job server is there. They are still in progress. So yeah, I need to wait a little bit. But I can switch to the backup one just to show you how the agent looks like. So my agent is, where's my agent? It's here. It's like that. And I had some jobs created. I will create the jobs, but the job is here. But the problem with that is that I cannot open that job. I cannot see the definition. I cannot create new job here. I cannot add credentials. I cannot add target groups. I can see them, the name. I cannot see what's in them. So that's a bit limited using the portal, which is a little bit frustrating if you want to do everything in portal. It's not possible here. So let's go see if my job database is ready. And it's done. So let's connect in Management Studio. I'm just going to show you what we have there. Aha. That's the wrong server portal, job server portal. That's the wrong server I created, or I created the database on the wrong server. Oh. Portal job. Here is the one. Apologies for that. Now, password. Yes, success. So I have created the database here, the Power Platform portal job, and I'm just going to show you that's empty. Before I create the agent, it doesn't have any tables or any procedures, any other objects. It's just an empty Azure SQL database, as you can see. And just a few steps back, when I mentioned the MSX TSX, that's my local instance. It's actually on Docker, but when you right-click on the agent here, you can see multi-server administration, and that's where you create master and target servers. I'm not going to do this now, but you can test it out on your local machines if you haven't heard about master and target servers before. I don't need this instance anymore, so let's close it. And let's see if my other resources created. Excellent. So now I have all my resources ready, all my two databases, my job database and target database. And I'm going to create the agent now. So I can go back to the quick access Elastic Job agent and create the agent, which will be called pp agent, no dash pp agent. And so I'm going to select the database. So I have two servers here, job server and target server. On the target server, I use the basic level. It doesn't show me the database. It's there, it's created, but it's not, it doesn't meet the requirements for the agent job. So I need to go to this server, and I have the database. As you can see, it's S0 standard. So I can pick that database, click OK, review and create. That's all I need to do in this window. I can download the template for automation if I want to, but it's just it, and it will create the agent for me. So I'm going to, it will take about a minute or so. So I'm going to grab the name of the target database, because I need to create the credentials, and we will be switching to the Management Studio. So let's connect to this. That's also an empty table, empty database, no objects. And in this demo, I'm going to create a job that will create a table in this database. So the job will be on the job server, and it will create a table here on the table on this PP target database. Okay, so my agent, I think it's in progress. So I need to wait a second before I carry on with all these procedures, because they might not be there. But let's see, refresh some tables, because it's in progress. So it might show up at least partially. That's there. So let's wait. Yeah, we have the internal tables. We will have the stored procedures as well, and they, when you look closely, they look very similar to what you can see in MSDB on SQL on premises, which that's why I called the job database MSDB for cloud. And yes, I can see them now. So I will be using the stored procedures once it's all done. Let's see if the agent is created. Yes, the agent is created. It's empty. It's just the agent. It has no credentials. So it's here. No jobs, no credentials, no target groups. That's the view for jobs. That was the view of the executions, latest 100 executions. And that might be the reason that we have the limited view. I don't want this page. That it's still in preview. It might change in the future. Who knows? That would be useful if we could manage the jobs from the portal. But for now, we can't. So I have T-SQL script that I need to connect first to the job server here. I'm going to connect to the job server. And this one, I'm going to connect to the target server. And that's exactly the same T-SQL script. That's just one T-SQL script. And I have notes what to run on which server. So this bit will be run on job server. This will be run on target server, and again on job server. So instead of having two scripts and trying to figure out what to do where, I have this in one script, and it may explain you the idea of the credentials and the users. So first I need to create on the job server, I need to create the master key encryption, master key, and it will be done in job database. In Azure SQL Database, you cannot do this use, and my database was pp portal job. pp portal job. Okay, you cannot use this, and you should click the proper button. The use statement is not supported in cloud in this solution, so you have to pick that from the drop-down list. So I'm going to create the master key in the job database. That's done. And I have two database scoped credentials. One is the job credential. This is the one that's responsible for running the job against databases, against the targets. And the refresh credential is on the target server level to be to enable the agent to see the databases on the target servers. But I created the credentials on the job database. That's done. And now I have to switch to the target server. The target server, I'm on the target server. So the logins go to the master database. So both logins for refresh credential and job credential will go to the master database. But the user for refresh credential go to the master as well, because that's where we are on top of the other databases. So I'm going to run this on master database on target server. That's done. And now I need to switch to the target database to create the user for job credential because I want the job agent to run jobs against this target database. So I'm going to create the user here. And that's an extra permission because I want this job to create some tables. So I'm adding just TDL admin role to that credential so it can actually do something. Perfect. So now that's the target. Go back to the job. On the job server, on the job database, I can create the target group now because that's the other component of the whole solution. So we're going to add the target group, just as proc sp add target group. And here is the fun part where we are going to add the targets. And because my target has different name, so I'm going to use this name. I'm going to use sp add target group member stored procedure, and it has the target group name, the one I just created, the membership type, which is include because I want to include that server, and the other type is exclude. The target type is SQL Server, and in the other demo, you will see that I also have the SQL Database target type, and the refresh credential, because I'm adding the whole server, the whole instance, and it requires the refresh credential to see the new any changes in databases. If we add new database or remove, it will see that change, and that's the server name. So I'm just adding that member, which is the one server. We can see and confirm what's been created, what's been added from these two views, target groups and target group members. So just very simple, the confirmation what I just added. You can also add the elastic pool and shard maps. And the next step, the last step of the solution is to add job. So I'm going to add the job just as we do on premises. Create a job. And here is the good part. We are going to add steps. So I have a job name because I need to link it to the job. I have a step name, and I have a command, the tsql command, and two things. Credential name is the credential that will execute the job. So I need this credential to be present in the target database, and the target group name. So as you can see on the step level, I can define the target group, which in the second demo, you will see the real difference when I'm adding each step to different target group. So let's add this step. And I'm still working on the job server. See, it's all on the first job server. It's not on the target. Similar to the previous, to the target groups, we can see confirmation of what jobs is created, what is the job step, credential, target group, all these different things. And now I can execute the job. I cannot do this from portal. Just right click and start. There is no thing like agent here in Management Studio. So I'm running this from the stored procedure on the job server. And it will run, depends on how busy Azure is, how big is my job, what it's doing. So let's see the view from jobs .job executions, and we can see few rows for just one. So there is one job, one step, but it has a few rows already. So I'm going to see, yeah, it succeeded. So the last message is step succeeded, execution on target, job execution succeeded. So you can see different things here about the job. It's not only job succeeded or step succeeded like on SQL Server on premises. It's a bit more detailed because we also have target groups. So my job was about to create a table on target database. So if I refresh that now, I should see the table, and the table is here, and the table is called table because I'm very creative in this field. So that concludes this part, but as you can see, you have to use two separate tools, the portal, Azure portal, and Management Studio. And if we go quickly to the agent here, it's actually refreshed. We can see that the job completed, and the job is here as well. And the target groups are here, but as I told you before, we cannot do anything with them. We cannot see them. So that's a bit painful. So yeah, that's how we create them in Azure portal and using T-SQL from the separate tool. Now, before the second demo, before the Powershell demo, let's consider why someone should create elastic jobs in their environment. So the most important reason probably is to duplicate the activities, the actions that they have in on-premises SQL Server, because in Azure SQL Database there is no SQL agent. So if you want to replicate the same thing, you would use elastic jobs. You can then automate management tasks, whatever you have. And the other reason would be to collect data in central place. So Elastic Jobs can read data from targets and feed that back to the central place, to the job database. And I will show you that in the second demo as well. So let's create some Elastic Jobs with PowerShell now. And that's my preferred way, because we can run the whole script. It will run, depends on Azure performance, it will run 10, 20 minutes, but it will create the whole solution. It will run the jobs and so on. But that would be very boring for you if I just run the script now. So excuse me. Yeah. The plan is the same. I'm still going to create the targets and jobs and databases and credentials and so on. But it will be done in PowerShell. For that to succeed, I'm using two PowerShell modules. One is AZ.SQL, the Azure module for managing SQL services. I think the latest version is 3.7.1 from this month. Maybe it's like 2 weeks old. And I'm also using the DBA Tools module. And if you are not familiar with DBA Tools, it's a community maintained PowerShell module to manage SQL Server. And you can see different functions here. I think it's over 600 functions, commands, PowerShell commands now. And there's a huge list of contributors. And I think recently they even finished the book here. So if you're not familiar with DBA Tools, just go to dbatools.io. And someone called them SQL Server Management Studio in command line. So you can do whatever SQL Server Management Studio can, but using command line PowerShell without clicking your mouse at all. That's very cool, very efficient, and I like it very much. So I'm going to use that PowerShell module in this demo. So let's see if I have my PowerShell modules. Yep, I have almost the latest version. I think DBA Tools is updated so often that it could be already 2 versions old, and I've updated that 2 days ago. But this means they will fix the bugs and add new features very often, so it's good to have them up to date. Okay, so I need my credential, the password that I was providing in Portal. So my very secret password. Add my password. Then I need to connect to my Azure account in order to use my Azure resources. I already did this, so I'm not going to run this command, but if you are running this for the first time, you will get a pop-up window to put your Azure credentials. So yeah, you need to have your Azure account ready to be able to do that. So I'm going to create a new resource group. That's one step that will be very quick. It should be very quick. And the method here, what I'm using is PowerShell splatting. So instead of providing all these parameters in line here, and this line would be very long, or I would have to break it into pieces, I can define my parameters before that and use that resource group args with $ here with the @ symbol. So it's very good to present the parameters and very clear to read. So I'm going to use that a lot. And I'm also intercepting whatever action I've taken as a variable or catch it as an object, so I can refer to that object instead of hard coding the names. So for instance, I created the resource group here. It will have all the details. So if I run this now, it have all the details about the resource group I just created. And then I can refer to that resource using the resource group name. So I don't have to repeat my name in the script. So that's how the whole script works here. If I make a mistake somewhere in the middle, then I'm in trouble. But let's hope it doesn't happen. So the resource group is created now, and I need to create servers. For this demo, I have one job server and two target servers. And based on my previous history with Azure, it might take between 3 and 15 minutes. Who knows? That's Azure and the power of cloud. So we'll see. So I'm going to kick this off and explain few things that I'm going to do later while this is running. Hopefully it's 33 on my clock, so hopefully it doesn't run too long. The next step would be very similar to the portal. I'm going to create the firewall rules, and one of the firewall rules was to allow my IP address to connect to the resources. So to do so, I'm going to catch my IP address from this website. I linked the blog post here. There are different methods to intercept the IP address. I just used that one. It felt the simplest for me. And again, in the parameters, here's my rule name, the IP address is my IP address, and the resource group name. And I'm going to create the firewall rule with the Azure SQL Server firewall rule. There's a good chance I won't be reading the commands in Azure SQL module, because sometimes they are very long and it feels like it's a whole sentence to read. So the script will be published. I will put that on my GitHub for anyone who is interested to play with the script. I will just give you an idea what I'm doing in here. So I will create that rule on my 3 servers, and the other rule is to allow Azure IPs to talk to each other. So 2 rules. Those 2 I checked in the portal when I was creating the servers. Once the servers are done, I will create the database, the job database. As you can see here, I'm using the SO level because that's the job database requirement. It should take about a minute to create one. And then I will create the Elastic Job Agent. Again, it will be about 1 minute. And you don't see many parameters here. It's just the command name of the agent. But I'm passing here the job database details because the job database will be created here. So this object has all the details about resource group, the server name, the database name, and everything is there. So it will be passed to this command. So I don't have to provide the whole line of parameters again. I'm just passing this, piping this, that's how it's called in PowerShell, to the command. So it's more clean to read and to understand what is happening. That will be done after the job database is created. And then after the agent is created, I will create 2 sets of databases. On one server, I will create a single database, and on the second server, I will create 4 databases just to play with the target groups. And it's 4 minutes, so it's a bit somewhere in between now. So hopefully it won't take too long. I can see the portal, how we are doing with the databases. So that's why I have the backup. I had the bad experience once and had to create the backup. The job server is, well, I think it's ready. But we are still waiting for the 2 other servers so I can run another script in PowerShell. So it might take few more minutes. Do we have any questions at this point? I don't know. Where's the chat? No. If we don't have any questions, I can show you what I'm going to do in this backup resource group. That's why I created that one. So the backup resource group has all the objects. So I'll have the.
Michael, actually, we are broadcasting this on Facebook Live, and actually, we are broadcasting this event to the Facebook Live, and few people are invited here. So still now, I don't see any question in the chat books. So,
okay, that's fine. That's fine. If anyone has any questions, I will share my email again after that. So hopefully I can help answering them.
yeah,
that's
that
fine.
will be better.
So yeah, so here we are going to create the server, the job server, the target servers, 1, 2, the databases, and the agent. And I'm just going to wait a little bit more for Azure to create the resources needed for that. Okay, so let's maybe keep talking about the plan, what we are going to do next. This bit might be interesting. I will still have time when I'm going to create the databases, but this is the bit where I am not using the Azure SQL module. I will be using the DBA tools here. So for job credentials, I'm using the Azure SQL because I need to create the credentials, and there is a command to create the credentials. But for login user combination, I will be using the DBA tools. So few words about that. There is a very universal command, invoke-dba query, which allows anyone to run a T-SQL against a server or group of servers, and that's from DBA tools. And my query will just create a login. There is a command in DBA tools, new -dba login or add new DBA login, something like that. But it was much simpler for me to just use the query. So I'm running this this T-SQL, and it's very similar to create the users. So that will be done in DBA tools. And here I'm going to create a refresh credential on a master database in both target servers. And this is the user in the in there. So yeah, that's what I'm going to create there. And this bit catches the databases from both target servers. And to do so, I'm going to grab the databases, get the -dba database from both instances, save them as a variable, and then loop through all the databases and create user and for job credentials, the one that is going to allow the agent to run a job. The extra permission is the DB owner because I want to do things, and I didn't want to limit myself or the agent to like some restricted permissions. I wanted to give them full power, but it's a good idea to think about this when you are creating the solution, to just not give too much power to your accounts, because it can cause problems in the future. If the job credential is too powerful, it can do damage if someone creates the job on the job server and, let's say, to drop tables. Yeah, it might be too powerful. Azure is really slow, at least this region. So let's see if it's still going. Usually it's done. Now it's 10 minutes. Well, I said 3:15, but wow, this one is just created. So unfortunately, we are a bit unlucky because this is taking longer than usual. I don't know why it's Saturday, but hey, it is what it is. And in Azure, we are never sure when, how long it takes. So at least that's my experience. Sometimes it took less than the range from the top, but the maximum was 15 minutes. So we are probably need to prepare for next couple of minutes. Okay, so I will carry on with explaining the script. After I grant the permissions and the users, I'm going to add the target groups. And here we are going back to AZ.SQL. We have the two commands, elastic job target group, which will create a group, and add elastic job target to the group. And again, I'm not passing the details of the group here in the regular parameters, just piping the group creation, which was the line above here, to the command. So it makes it a bit easier to write and less characters used in the script. And there will be three groups from this demo. The first one is for two instances, for two full servers. The second one is for single databases, each from one from each server. And the third one is all databases from one server, excluding a single database. So the difference between these two parts is, as you can see, I'm using the same command. Yay, we are back here, 11, almost 12 minutes. So I will go back to this one because we still need to create the database. So let's bear with me for a second. So we just don't wait longer than we need to. Okay, the target servers are created. So now let's go back to the firewall rules. We can create the firewall rules now. It shouldn't take too long. It's just switching the values. Yay, it's here. And now the agent. So I'm going to create the agent, the job database, the agent, and the target databases in one go. So we don't have this break because that will take, again, few more minutes, maybe 5 or maybe 10. Let's see. So while it's running, let's go back to the groups. The first group is the whole server. So I need the refresh credential parameter to be passed, to be set, because the group is the whole server, and the agent needs to know if there are new databases or the databases were removed from the server. So that's why I'm using the refresh credential for this type of the target group. The second target group is just a single database from each server. So I don't need to provide the refresh credential name because I don't need the agent to know anything about other databases. I just need to know about this database. So I need to provide the database name. The server name is here as well, but I don't need the refresh credential. That's what is that is the role of the refresh credential, to see all the databases. And in this example, I don't need that. It just points to a single database. So if I remove any other database or add new database, this doesn't affect this this target group, this job. The job will still run on these two databases. And the last group, it looks a little bit complicated, but I'm creating the target group. Now from the server one, I'm getting all the databases, and in the loop, I'm going to add the databases to the group. So I'm adding the databases individually, not just as a server, but individually as database by database from the server 1. And then using it might be counterintuitive, but using the command add, I'm removing one of the targets. But it's not just removing it from the table. So it will be added to the list, but with the flag or with the property exclude. So as you can see, when I run the script, you will see the output. All databases at first will have the include property, and then one of them will have the exclude again. So it will be listed twice. Yeah, so that's the plan. The Azure doesn't like me today. That's taking too long. I wonder if I choose different environment, different region, it would be quicker. Come on, US. So that will create the target groups that will leave us only with the job. And my job that's going to run for the demo is going to have 3 steps. Each step will be executed on different target group. And to show you that, I'm going to create a job. Each of the steps is creating the table that's called step 1, step 2, step 3, depending on which step is that. And each query will be run against the target group corresponding to the numbers. So step 1 and query 1 will be executed on target group 1 and 2 and 3. And that means that the step 1 table should be created on all databases from both servers. Step 2, just on databases. There's 2 databases I pointed here. And step 3 should be created on all databases from server 1, but not on this one I just excluded. Hopefully that we have time. I have 10 minutes. Come on, Azure. Push it a little bit. And yeah, so once it's done, I'm going to execute the job, and we'll see it will create all the tables. So hopefully it will create the tables. Yeah, I don't know what to say. Why it's taking so long? It's very unusual for me, at least. So yeah, apologies for that. I had two demos for that, but I'm not sure if we can make it with this time schedule. I don't want to overrun because I think Damian is next in the queue, so I don't want to overrun, but we have to wait. I can only show you the backup job. Is it here? So the backup job that I created before, it failed, but it failed because one of the databases is the master, and I didn't create a credential, the job credential in the master database. So yes, it's finished now. Well, yeah, target grade, perfect. So let's see. Let's hope we can finish that. Okay, the databases are created. The target groups, the job credentials here. So we need to create the credentials. And we need to create the users and logins. That will take a while because it needs to connect to each database, but it shouldn't be too long. Again, this bit with creating the groups and the job shouldn't take long. The longest is to create the resources, or maybe because it's Power Platform, global Power Platform Bootcamp. That's why it's having some issues with performance today. Creating the target groups, creating the Elastic job. As I mentioned before, we can see the include membership here. It's include because I'm including the whole server, the databases, the individual databases, and the last one is excluded because I specifically said exclude that database. Now I created the job with the 3 steps, and I'm going to start that job. While this job is running, I can see the executions. I can see it's executing on different databases, so it's in progress, and before it will run for some time. So I will quickly create the second job that is going to collect the data from target servers, and we will go back to this one because we need to see the tables. So let's create just a new credential, a new login, and the role, because I'm going to read the data from target servers. So it's the job collection credential. I'm going to create that, the users. That's quicker because I don't have to create actual databases. And with DBA tools, I can create tables as well. So there is a command new -dba db table, and here's my definition. And on each server, I'm going to run a query. What is the server name and what is the timestamp? But the central table requires this first column, internal execution ID. And that's a unique ID that will be on the job server. So I'm going to create that table now. And as you can see with DBA tools, we can create objects in Azure as well, not only on premises. And I'm going to create the job that just runs a select. So it doesn't do any changes. It just reads, the get date, which is the function to return the timestamp and the server name. So I'm adding this. I created the job, and I'm going to start this job now. Okay, whew. This job is running. Let's go back to the other job. This should be done now. It succeeded. Yeah, perfect. So now I'm going to see the tables on those servers. I'm not using Management Studio. I don't want to go to Management Studio, but I'm going because there are 2 servers and 5 databases. I don't want to connect to each just and refresh to show you the tables there, the tables there. So with the DBA tools, I can get DB tables, the DB table, and get the list of the tables from both servers. It will run a little bit, and I will sort that by table name, because that's how we created the tables. So a few more seconds. And yes, it's done. So we can see that the table number 1 from step number 1 has been created on all databases, because in the target group 1, I added both instances, both of them. So the table 1 has been created on both servers. The target group number 2 had just 2 databases, database 1 and database 1.1 and database 2.2, and the table was created there. And the target number 3 had all databases from instance 1, but I excluded the DB11. So the table from that step is created just on these 3 tables, which worked. Okay, that's cool. And now let's see the other job. So this job should be done now as well. Is it done? Succeeded. Excellent. So I'm going to run the query. Just select star from collection central output, because that's how I created the table. And it shows me that it's not very useful result, not very useful query, but it shows me details of each server because I executed that query against every database. So 4 of them were on server 1, 1 was on server 2, and the timestamp is here. It would be probably useful if I add the database name here. So I need to change that. But we also have the internal execution ID as an extra column, and that is the data collected on the job server. So I don't have to go to the target servers anymore. And the only difference comparing to the previous demo, here I will just split that. It's I should use the splat method here as well, but I'm just going to show you that I'm adding the step as in the previous demo: name, target, credential name, command text, and here's the difference: output schema name, which is collection in my case. I just named that. It can be anything. Output table name, central output. Again, this is my invention. Output credential name, the job collection. So that is this extra credential that I just created for this purpose. And the output database resource ID, which is telling which the database is collecting the output. So that concludes the demo. In summary, the Elastic jobs in Azure SQL Database are fancy SQL agent jobs with more functions than just SQL agent jobs on premises. You can create them in Portal, but you need to add some other task, some other tool like PowerShell or Management Studio to run some T-SQL commands, because it's not possible to create the whole solution in Portal. And you can also create them in PowerShell. Like in my example, I used AZ.SQL and DBA tools to run the whole solution within one file. And if I run this file, select the whole script or just run the script, it will create everything in 10-20 minutes from the scratch to the end. And that's brilliant. So I think I made it. I'm Mikey Bronowski, and if you have any questions after that, please reach out to me at mikeybronowski@gmail.com, and I'm happy to be here. Thank you for having me today at your event, and hopefully the rest of the day goes smoothly as well. Sorry for overrunning a little bit, Damian, and everyone.
Oh, Aksan, you are on mute, so please unmute yourself.
Oh, sorry. Thank you very much, Michael. It's a great session for me. Also, those those who wants to make his life easy, and the automation absolutely makes life easy. Thank you very much.
Thank you.
I just want to introduce to our next session that will be taken by Damian. Thank you, Damian, for your time and effort for the community, and I think the event will be very much enjoyable, and because it's a cutting edge of technology, Azure Synapse, I think all people love to for this session.
Yes, so Synapse is one of the most important service, I think, in the nowadays and of course in the future. And by the way, what Mikey was talking that today we experienced some problems with Power Platform. I don't know if it is really related to the Power Platform Bootcamp, but it's really true that today there are some problems, because I already did one demo in the morning for Power Platform Bootcamp in Lisboa, and for example, the virtual agent was not responding for a quite long time, which is unusual and have never happened again previously. So probably something is because of many people are trying today, doing some demos. There are some problems, but hopefully there will be no problems with signups today. So I should have this. I should, I think, share my screen. Yeah, that's me. And it's quite interesting story behind this picture, because this picture was done after 6 hours of, wandering in the mountains. So it's when you are almost dying on the top of the mountain. So this is how you look. This is how you look when you do a lot of coding as well. But let's concentrate on signups today, because that's the main actor of the next hour. So I would like to tell you a little bit about Synapse Analytics and how to do exploratory data analysis using Synapse without investing too much in the creating the environments and building the environment. So you can do it basically from scratch. And this will be the idea for this meeting. And at the end, I would like you to see that this is something that everyone can start with. You do not have to be a data scientist. You just need to have a basic knowledge of SQL. You have to know how to write a basic select statement, and that's all. And you need to have data. This is what you need. So my name is Damian. Let me introduce myself very quickly. I promise this will be a better picture here now. So my name is Damian. I come from Poland. I am a Microsoft MVP since 2009, so quite a long time. Also, I'm doing a lot of trainings and work for company Uvik. In Poland, we have our data community, a very big data community, and we organize a lot of conferences, and one of those is one of the biggest one in Europe is so-called SQL Day. So the next SQL Day is in May. It will be partially hybrid, so if for people who cannot attend in person, you can always join online. Yeah, that's all about me, and I would like to tell you about the history when Synapse started and what problems it tried to solve. So basically, when we think about Synapse, we know that previously it was called Azure Data Warehouse. So as a data warehouse, we know that data warehouse is something when you have everything prepared and designed very carefully, and every table has a defined shape. If you look inside a table, you have a set of columns. Each column has its place, has its meaning. So to create a data warehouse is basically a very long-term job, but it's also very boring. So if you think about data warehouse, usually it takes 6, maybe 9 months, sometimes longer to build it. And requires, from my perspective, a lot of paperwork, because you have to prepare a good documentation to understand why we have tables there, what each table is all about, and what is the purpose of each of those tables. So on this slide, you see I have visualized the tables as a bottle of bottles of water. So you can imagine that if you would like to bring another bottle here, it's a very simple task. But you see, take a look how beautifully the bottle of waters are placed on those shelves. Everything is it is in its position. You know why the bottle is there. But you can imagine how much work it requires to keep this beautiful, to keep those shelves tidy and without mess. It's a lot of work. There is, however, several problems with, let's say, classical or classic data warehouses. Because, when you build something like this, you have to think about so-called storage, so how much data you can put into this, and of course CPU. CPU means that you have to pay for the processing power. Also, when you build a warehouse like this, it's not easy to extend the data warehouse, because you have to think about that your data warehouse will always grow. You will never shrink the data, because you have to keep historical data as well. So in one data warehouse, you have to keep data that are hot. So you have to think that for example, I do a lot of reporting, let's say for the current month or maybe current year, but then I have a lot of data from previous year, which I call warm, because I can do also a lot of reporting, like referencing reporting. And I have a lot of data that I can call them cold. So those are data, for example, 5 years old, which are accessed very infrequently, but I need to keep them. I need to keep the data because for different reasons. Because, for example, the data warehouse has to have all the history. So it becomes a very costly solution. It looks like this. Most of the time you build on premises, you have to have a lot of compute power and a lot of storage. So extending this means that instead of buying one hardware, you have to invest immediately in, let's say, another set of hardware and maybe even more. So it's a very costly solution. But the situation is even worse, because, what I was trying to explain is that the very ideal world. So I still think that having this, let's say, data solution, you can have it. But from the perspective of real life, it is almost impossible that you will be able to create a data warehouse in that way in the first place. At some point, you might be able to build a data warehouse like this. But imagine a situation that you have data and you would like to just take a look into the data and perform some kind of analytics to have quick answers. Let's imagine that business people ask questions. So you don't want to tell them, hey, I need to build a data warehouse like this. Let's get back to your questions in 9 months. Because business does not work that way nowadays. You have to have the answers almost immediately. The other thing is that we have a lot of data from different data sources, not only relational. Most of the time now, the data is non-relational. So you have a bunch of files. With the files can have a structure which is changing very frequently. So most of the time we do not think about data warehouse, but we think about something like this, which is a data lake. So the data lake can be, it's a storage. Technically, it's infinite. So there are no technical limitations how big the data lake can be. And you can put anything to this data lake in the native format, because the data lake does not have any assumptions about the data format. You can put big files, you can put tons of files that are smaller in size, whatever you wish. You just need to put the data in it. So, but now there is a problem. Imagine that you have to build a data lake, which is kind of simple thing. So you build the data lake, and you have your data there. Some of those files are very useful, and you would like to analyze them very quickly. So imagine that the idea is that the useful data you would like to analyze now, the data is in all the green bottles. So how would you like to analyze data from this data lake? The task is that you need to take all the green bottles and analyze the data. How would you like to do this? And the answer is very simple. You need to do it very quickly because you don't want to swim in this data lake too long because there are too many other data. So how to do this? And the answer is simple. Use the fastest language possible. The fastest language possible is called SQL. SQL is the fastest language for data analytics. Also for data analytics on demand. And the data analytics on demand is something that I would like to present to you today. So Synapse is the, let's say, it is the central part of the modern data warehouse architecture, as you see. So you see Synapse is somewhere on the right-hand side in the top. On the left-hand side, we have the data sources, which can be literally anything. So there are also no limitation what the files are, what is the data source, could be literally anything. Then most of the time, this is only a referencing architecture. This does not mean that it has to be always this way, but at least you know what you should have. So if you would like to get the data from the data sources, most of the time you have to have some kind of engine that can take the data from the data sources and put to the data lake that I have mentioned. So most of the time you would like to use Azure Data Factory as the orchestrating engine for this purpose. But I can also imagine that it can be like a Azure Function or Event Hub or Stream Analytics or whatever service that can take data from one place and put the data to another place. In this Azure, if we think about Data Factory, you can also imagine that you can perform some kind of transformation while moving the data from source to the Azure Data Lake storage. This is not always mandatory because let's say the pattern is not like extract, transform, and load, but it's a little bit different. It's like an extract, load, and transform, which means that transformation is not done in the data factory, but it's also possible. So what we can do if we have already data in data lake storage. So most of the time we think about big data volume, at least. So you have a lot of data there. What you can do, you can build your machine learning models or perform very advanced, let's say, data transformation using Databricks cluster, because you can then use, for example, Python or Spark languages or SQL, Spark SQL, to perform this type of analytics. But the same thing you can also do in Synapse. And this type of analytics I'm going to show you in a moment. So once we have this analytics done, then you can do reporting or you can build analytical model depending of the needs. So this is the architecture that as of now exists in the cloud, and I think we should follow it as much as we can. So what is Synapse actually? So Synapse is, previously it was Azure Data Warehouse. So we have thought about Synapse like a data warehouse, which is in the cloud. So you still have a bunch of tables. You can create views, store procedures, databases, like something like this. So this is still exists, and you can build this type of structure. So let's say regular data warehouse on so-called dedicated SQL pool. So this is what does it mean? This means that you have a predictable performance because each of the dedicated pool, it has a number of so-called data warehouse units. And those data warehouse units are like a processing power. So the more you pay, the more power you have. And of course, you can also scale it up and scale it down. Unfortunately, this is not done yet, let's say, in automated way. So you have to perform those tasks by yourself. But then there is a new kind of pool has been designed by Microsoft team. They design serverless SQL Pull, which means that this is some so-called on-demand. So the pool is always available for you. However, you cannot control how much power is inside the pool, but you can do on-demand tasks without investing too much into the let's say building a data warehouse. So this will be a perfect solution for extrapolatory data analytics, which is a topic for today. And it's also very important because you are only paying for the number of terabytes you have processed. So it's not related, you are not paying per hour, you are paying per the number of data you have processed. But this is not everything. It turns out that Microsoft also integrated Spark engine. So you can see Apache Spark integrated there. So imagine that now you have 3 engines inside Spark Analytics. You have you can build a regular data warehouse on a dedicated pool. You have on-demand analytics, and you have Spark engine, which is like a Spark cluster. You know it from Databricks. So now you can think about that, okay, maybe I don't need the Databricks anymore. But if you have it already and you perform a lot of analytics there, you should keep it. But for new solutions, maybe you have a choice. And of course, you have also pipelines. So then you can think, okay, if I have pipelines, so maybe I don't need Azure Data Factory anymore because I have pipelines which are also integrated in Synapse Analytics. And of course, there is a tool which is called Synapse Studio, in which you build everything and you put everything together like puzzles. Now let's talk about the demo that I have prepared for you today. And the demo will be done on the real data. The data I found on University of California in Davis, nearby Sacramento. And what they did is that on one of the highway, which is called Interstate 80, they put like 50 something, 57, 58 so-called measurement gates. So the idea is that the gate was measuring how many cars go through the gate every minute, and also measure the speed. But it was not because they want to, they want to call the police if you just drive too fast. The idea was that they wanted to have information how much this highway is loaded. Because it was a plan to perform some kind of, rebuilding of the highway. So they wanted to know whether it is, when this should be done. And I have, of course, you can, from the University of Davis, from their webpage, you can download data from all the measurement station. I have information from 5 of them, but it's a lot of data. So I downloaded the data to Azure Storage. The data is in Parquet format. So it's already prepared to be in a columnar format. So the columnar format is the preferred format if you do a lot of analytics, because in such case you can apply this directly to, for example, to Spark engine without the need of transformation. And of course, this serverless pool also works the best in the if you have data already in the Parquet format. If you think about, okay, if I have data in CSV file, what should I do? Then just do a simple transformation. The simple transformation you can do in Azure Data Factory. You just take data in CSV, save the data in Parquet. It's just in one step. It's very simple task. So it's like a pre-processing that should be done before you really go to the Synapse. So that's this one. This could be this step, for example, here, right? So you just need to, the transformation means that you just change the file format. Okay, so first of all, I have already created Synapse. So let me go to this one. So, you know, creating a Synapse is a pretty easy task because you just need to go to the cloud and type Synapse and create Azure Synapse Analytics, which is like one step, task to do. So it takes like a few moments to complete, but it's very easy task to create. I have created it before, so I'm going to use the Synapse that I have now, as I have created previously. And I have one more thing here. This is the storage that I have mentioned. So I have a storage, data lake storage for different demos, but I have my storage, which is called Flow. And inside the Flow, I have data from 5 stations. So this is the initial state we have. The data is in the Parquet format, and as you see, it's a lot of the data from each of the station. So each of the station has a bunch of files, and I'm going to read all the files immediately inside the Synapse. So from the Synapse perspective, once the service is up and running, what you can take a look is, first of all, that you have this serverless pool. But the serverless pool, you cannot do much with this because the serverless pool is always available. But as I have mentioned, you cannot control it. So you do not have the predictive performance on it, but you can do a lot of on-demand tasks. If you wish, you can create the regular, the dedicated Synapse pool, and then you can decide how big the pool should be. But you know, the case is here that there is, as of now, there is no automatic, like auto-inflate or deflate the pool as you have, for example, the capability in Azure SQL Database, where when you have a serverless model, you can decide the parameters. This is not serverless model, so you cannot do this. You can make it using scripts. So, for example, PowerShell script can help you here because you can imagine that, okay, if I do a lot of data loading and data processing, I would need to have more resources there. But later, once the data warehouse is up and running, and maybe the analytics is also up and running, you can set the resources to some kind of lower level. But this must be your action. So you can create pretty easy and pretty quickly an additional pool. Same story will be for Apache Spark. So as of now, when you install this service, so I mean Synapse Analytics, you do not have any Apache Spark pool because it looks like that, it's entire compute cluster. So in this cluster, you can decide how big the cluster should be. So for example, you can decide, I would like to have the minimum 3 nodes and the maximum is 200 compute nodes. Each of the node is this size. So take a look how big cluster you can build. This is the price you need to pay. And of course, you can decide what kind of cluster you would like to build. Hardware accelerated, I would say this is for calculations like you have a neural network, you would like to train a neural network model, for example, for image recognition or something like this, which requires a lot of computational power. In that case, of course, the nodes can be even bigger. Imagine GPU, 64 core, each node, 0.5 terabyte of data, of RAM, of memory, and you have 200 nodes like this. And you can run your code on such big cluster if you need it. So that's a very similar configuration to what you see actually on the Databricks. But I'm not going to create this cluster. I'm going to use today only what you have built in. I will be using all the calculations on the built-in serverless pool inside my Azure Synapse. So if I would like to start the my journey with the data, I would have to go to Synapse Studio. So I have already opened the Synapse Studio, and it looks like this in the first place. So first of all, that's the visual place and the visual interface in which you can do everything what you need, including also management of the data connection. So you can imagine that you can, for example, you can create a link service. So that's like a connection to a different data source. And there are like, I think, 50, 60 or even more ready-to-use data connectors. So you can connect to many different data sources. And once you create this connection, then you can just connect and read the data using regular SQL command. Of course, from this perspective, you can also control, so to create a new SQL pools or create Apache Spark pool, whatever you need. And also administrative tasks like access control and credential. This is the part when you can build pipelines. So you can build a new pipeline and you can say, I would like to copy data, right? So what is the source? What will be the location? So the source could be, for example, connection to the CSV file, and the sink, I mean the destination, would be the Parquet file. So this is how you can do the transformation that I have mentioned earlier. So it's pretty basic thing here. But what I would like really to do is to show you how I started my analytics on the data that I have from the University of Davis. So first of all, what I have created is I have created a view. If you have ever worked with databases, then you know that most of the time, unless you create an index view, then a view does not hold any data. So it's like only a definition. It's like a query definition, which is stored as a view. And take a look. In my view, what I do is I'm connecting using open row set function to my data lake, to this measurement station, and I pick all Parquet files. Then I do, of course, there is also, a condition that when particular column is greater than 0, and I will explain you what the column is. You will see it in a moment. And take a look. I do it. I'm performing select. I do union all. I'm taking data from another station and another station and another station. But this is, creating a view is not running a query at all. It's just like a definition. So I'm creating the definition, and it says, no, something is wrong here. Object is in the database. I should have started drop view if exist. That should be my first statement. So let's do it one more time. So query executed successfully. And then what I would like to do, I would like to take a look, what do I have in my data? Because I'm starting exploration of the data. And in a moment, I would like to show you how can we perform a little bit of data science using only pure SQL without doing anything in Python or Scala or any other languages, mostly Python, of course. So let me do top 10, select top 10 from view. And now it's the moment when the data is really accessed. So imagine that there is a storage and I'm performing select top 10. So I don't know what 10, what kind of rows do I have. It will be just first 10 that is accessible. So now I have information what is inside the files. So you see, this is the data is about the road, right? About highway. So we have information that for every lane on the road, we can measure how many cars there were. What is the occupancy in percent? So this is like 3% of occupancy. This is 8% of occupancy of the lane, and the speed, the average speed of those 6 cars. And as you see, we have 2, we have 3, up to 8 lanes. And this is the measurement station name. But as you see, we have a bunch of nulls, right? And only 3 lanes are actually sending some data. And the lane starting from lane number 4 up to lane number 8, they do not have any data at all. So you may ask a question, is it an error in the data? So something is wrong with the data, or this is the desired result? How to check it? You see, now we do the analysis, right? This is data exploration. So what should we do? So my idea was to open Google Maps and go there, and I will check what was the name of the nearby village. It was called El Macero. El Macero. Oh, this is here. Let's make it a little bit smaller. Oh, that's the highway. That's the highway. And you see we have data from, so that's the University of Davis, and that's the highway Interstate 80 with those 50 something measurement gates. So how do I check whether, why do I have only data from 3 lanes and not from 8? So I did something like this. I put the guy here, and I try to let me go to this, highway here. And you see, that's really true that we have only data from 3 lanes because there are only 3 there. So lane number 4 up to 8, they do not contain any data because there are only 3 lanes on the road. So that's really a good result. So I don't have any initial error in my data, which is fine. The next step, what I would do is I would go and take a look, what is the data distribution? And this is pretty easy SQL query, right? For each station, measurement station, I would like to count how many rows do I have from each of the station. I am performing group by grouping set operation. So now I'm aggregating data across all the stations that I have. So now you can imagine that I have millions of files and I'm trying to read information from them. It should be like in a few seconds. So take a look. So I have data from each of the station. Those are the number of rows, and this is the total number of rows that I have. So 1.3 million of samples, data samples. And then I started one more query. I hope I have the result already there. You know, this is the type of query which we usually don't run because, you know, when you perform analytics, analytics means that you are doing some kind of summarization, statistical view on your data. So the statistical view means that you are not doing select star or select columns from, right? So this is not analytical query. As it is not analytical query, it took 90 seconds. So, you know, I don't want to you to wait 90 seconds for the result. So I started the query prior to our meeting. Now I have results. And you know, the reason I like the Synapse Studio very much is that I can view my data in a tabular format, which is one thing, but I also can see the data in some kind of visualization, so I can imagine what really happens. So I try to configure the chart. Let me put time on the x-axis here, and on the y-axis I will show you what we can see. So first of all, we will see the flow of the cars. So you see that there is moment when there are like 20 cars during the day. Then If there is late night, like 1 a.m. in the morning, we have only 4 cars. And then we have again during the day many cars, and at night we have again the road is almost empty. That's flow 1, which means you are on the lane number 1, which is in Europe and United States, is on the right hand side. It should be the most frequently used lane. Then you have a flow on the lane number 2 and flow on the lane number 3, which means that the third lane is only usually for the cars if you try to if there is no place on the first 2, right? So this should be the least usable lane. And as you see, it's like this. We can also compare the speed. So what is the speed on the first lane? What is the speed on the second lane? And what is the speed on the third lane? And you see it's almost the same, right? So it's fine. So the car are moving just in the parallel, like in the parallel. But then you may ask a question to yourself. Maybe there are some dependencies, right? So maybe I can find a dependency between the flow and the speed. Maybe there will be a dependency. Maybe, on this chart, we cannot see it very well, but during the day, you have the speed is a little bit less. Take a look, 70. And at night, people are, sometimes you see 80 something and more. So maybe we can create a model, the simplest one you can imagine, that can help us analyze the data. And having a data model like this, we can perform a lot more advanced analytics. And that was my goal for this type of data. So first of all, I'd like to tell you where we should go. And then I will explain you the rest of the demos. So let me just, I think I will be able to draw something for you. You should be able to see my notepad. My OneNote. And the idea here is that I would like to create a model of the simplest model you can imagine. It will be a regression model, the simplest one we can have. Where is my? Yeah, it's my notepad here. I'm trying to find the when I. Yeah, okay. Now I see where am I on the page here. Okay, so now I can draw all the necessary things. So my idea was to create a model which will be like this. I would like to create a linear regression, and linear regression is the simplest model that can be understand. It looks like this. So you have an output, and the output is a linear. It's a function in linear function of the input, and we can have data in a format like this. So imagine that we have this x-axis here, we have the y-axis here, and we have a bunch of points, measurement points taken from the measurement station. And now the question is, what type of function should I pick? Because you can imagine that one of the functions that you could pick could be something like this. But this is not type of function we can see in the real life because it's too complicated. So you can think about this function, this red one, as the function that only works or will work with this particular data set, number of points. This function will not work in general case. You should always start with something simple. It should not be too simple, but it should be simple enough to describe the reality. So we can say that we'd like to find a function that looks like this, right? But then you can ask me, hey, and what about another function? Maybe a function, this one is better. Or maybe we have another function, and maybe this one is better. Which one fits the best? That's the question here. And that's the question that we have to answer using our SQL statement in Synapse. And if you ask me, hey, where those functions are, do we really need that? Think about simplest transformation of the temperature. So if we have a Fahrenheit temperature, you know that this is a very simple calculations like this. Right, so that's the transformation we do for the calculations between Celsius and Fahrenheit. I will change it a little bit because I'd like to put it in the form of the coefficients that I have below. So take a look. This is something that I'm going to predict. This is the prediction, right? This is the coefficient which is called A. And what is the physical meaning of it? This is the 32. This is a temperature. So anytime you do a linear regression, so the coefficient which is called A has to have the same meaning like the output. So it has to be in the same dimension, which means that if the output is a temperature, that also A has to be a temperature. And then you have a scaling component, which is this one. And this is the second coefficient that you can control to choose the proper line. So depending on A and B, you can choose line 1, 2, or 3, or maybe some other lines as well. So I will show you in a moment a general expression how to calculate A and B, because those calculations I use in my demo. But first of all, we need to decide which line we'd like to pick. And in general case, what we'd like to achieve is to have a line which fits the best. What does it mean? And I will now draw, a simple case. It will be very simple, but I hope you understand what do I mean here. So first of all, where are the coefficients? So A and B, where can we find them? So the coefficient A, and if you take a look here, so the coefficient A will be visible in a situation, in our case, when C is equal to 0. So then the temperature should be 32. So this is actually the A coefficient. So it's called, if you go to literature, go to the books, this is so-called interception. And then you have a coefficient B, and it looks like that B is somehow related to this angle we have here. So the bigger the B is, if the B is bigger, then the angle is also bigger. So you see, it looks like this. So the more B you have, the bigger the angle is. So this is what we this is how we understand those coefficients. And the definition of the best line is a line that minimizes the error between the point that was that is predicted. So we can call it like this, and the point we have really here. So in each place of the line, we can find a point that we have. That's the point we have from measurements, and that's the prediction. So what we would like to do is we would like to minimize the difference between those points. And in the first glance, you can think about, okay, let's minimize a difference like this. So I would like to keep on minimum level something expression like you see on the screen. But then you may think that if this error has a plus sign and this error has minus sign, so if you just calculate the expression like y predicted minus y actual, this is y actual, so then having a situation like this, you might end up with error which is equal to 0, which is not true because you have an error. That's why what we typically do is we try to square it. And then really the case here is to minimize so-called a function, which is called cost function, which is sometimes called Q. And the cost function is to minimize the error, which is described like this, that we'd like to perform a summation of the differences between the predicted value minus the actual value. In each of the point we have, right, squared, and then of course we can perform a square root from it to perform a very familiar calculation. So that's a little bit of math, but now I will just tell you a little bit, and this will be, I promise, this will be the last math you see, but you have to know it because then I show you how I implemented it in SQL. So the A coefficient will look like this. So let me scroll here. So you see the A coefficient. It will be the sum of the Y multiplied by the sum of x squared minus sum of x, sum of xy divided by the number of samples you have, sum of x squared minus sum of x's. And the B coefficient will be very similar. It will be sum of xy minus sum of x, sum of y. And here we have the squares minus, but it's a little bit, it's y here, not x, it's y here, squared. And there is also R coefficient, which tell you how good the line fits to the points. And if you think that I am smart enough to remember this A and B coefficients, that you are wrong. I just went to the web page which has all the coefficients described, and I put the numbers here. And the reason is only one, because I would like to show you my actual implementation. So I have 10 minutes and it's just the right time to finish the demo. So first of all, before I go to the statistics, I would like to show you the remaining part of the analytics that I have done on my Synapse. So first of all, I wanted to see how much my lane number 1 is occupied on each of the station. And the result I'm expecting is like between 0 and 1. This is something that we should see on each of the stations. So you see it's mostly true. So we have 0 and 95%, 91. But on the station number 62, you see that's only 39%. And it looks that there were some road works. So it was not possible to use all the lanes and have the occupation close to 100%. I have created one more view, and the view was defined like that I wanted to have all the possible statistical functions that SQL Server exposes. So take a look. I have minimum, maximum on occupancy, flow, and speed. And then I wanted also to have average. And I wanted to have standard deviation, right? Because if I have only average, then it's not possible to get some meaningful results. And now we have this coefficients that I draw for you on the on my notepad. This sum of y, it's described like So that's the sum of y. You see it here. Sum of x square, it's this one, right? So you can refer to this notes if you wish later. So this is how I created those coefficients, and those are real data. And first of all, I started to have it from one station to make sure that I can understand what's going on. I created all the necessary sums, and I created my first approach here to make sure that I understand how the coefficients looks like. And take a look, that was my first result, but you have to first ask the question, what am I analyzing, right? So I'm analyzing flow on the first lane, how the flow on the second lane, so that's my y, so that's the prediction. So what is the predicted flow on the second lane if I know everything from about lane number 1? And those are the coefficients. So you see, we have a coefficient. A, which says that you have to multiply. That's the interception. So and then you have to multiply the number of cars on the lane 1 and add this one, multiply it by 0.61. So you can say that that's very closely. You can say that on the lane number 2, you have around 60% of cars from lane number 1. This is what is the meaning here, plus 2, right? So if you have, for example, 18 cars on lane number 1, then 10% is 1.86 times 6. So it will be half of them. It will be 9 plus 1.8. It will be 10, 13, 14. 14 cars will be on lane number 2 with probability 84%. So this is how we can read it. But then I created also a view which I'm going to show you now, because I was very curious about a view in which I can say something about the speed. So if there is a correlation, linear correlation between the speed, between the flow, how many cars do I have, and also the speed. So the speed is something that I would like to predict basing on the flow that I have on the lane number 1. So I have created a view that explains this situation, and I would like to run the final query for you just in a second. So let me show you this one. And we should have the answer pretty quickly from all the stations. Information that, take a look. We have the A coefficient, and I have told you that the A coefficient has to be in the same dimension, so it has to be the same physical representation than the value you predict. So in my case, as I am predicting the speed depending of the flow, so that's the initial speed you have. So on the lane number 1, you have 78 miles per hour, which is kind of big one. And then the coefficient B has minus sign here. What does it mean? That means that my line is not turned, it looks like, I will show you this quickly, which means that I have data like this. So I have 78 miles per hour, but the B coefficient is less than 0, which means that, and this is the flow. So I have some kind of numbers. If it is less than 0, which means that if I have more cars on the lane number 1, the speed has to be smaller. So this is something that we can also imagine that it should work this way. And I have this information also from the data. And to conclude my session, think about it this way. I have a question from business, which they want to know how should we interpret the data? We have a lot of data, but we don't want to build the entire system around this. First, we'd like to perform some kind of analytics on the fly without investing too much into infrastructure, just taking the service but not investing, in building the data warehouse and analytics. I just use a SQL Server capabilities and SQL queries on data which are stored in the files, and I have them in the data lake. And I use the regular SQL statement to create a linear regression model against the data. So if I'm happy with the model, I can perform a lot more advanced analytics. But I started with something very simple, and this is why I think Synapse will be the perfect solution for you if you would like to start your journey with playing around your data. And having said this, I would like to conclude my demo. I would like to thank you very much for having me here in this excellent event. I'm very happy to be here with you. I hope it was exciting day for you all the day long, and I hope also to have the possibility to join you once again. Thank you very much. And you are again on mute.
Thank you, Brian. It's a very interesting session. I think
Thank you very much.
we need few more session on Synapse. If you can.
Yeah, it's very.
Make me happy.
Very keen that the service is there and it has a lot of possibilities. And as I told you, it will be the central place of the analytics solution that
Right.
we will build in the future. And I see a lot of excitement on the market as well. So people would like to use it very much because of this enormous capabilities it have. So I think it will be good to know as much as we can about it.
Right. Thank you, Brian. Hopefully, in coming days, we will arrange a few more sessions on Azure Synapse. And we also thankful to our speakers. They have given voluntary time and effort for the community. And we would like to inform you that in next month, 19th of the March, we are gonna arrange another session on that will be a monthly meetup session. And I hope these sessions will help you to skill up your skill matrix, and as well as it will help your career and the company you belongs to, and the productivity will be definitely up. I think the community would help the people, IT people around the world, because it's an online session, and around the world everyone can watch easily through Facebook Live or joining in the meetup or Microsoft Team. Thank you everyone till the next session. Thank you everyone. Hopefully for the next session, next month, March, we would like to invite you, and that will also be a interesting few more interesting topic will be arranged. Thank you very much. Thank you everyone. Thank you, Brian.
Thank you. Have a great day. Bye.
Have a great day. Good evening.